So what we're doing today is we are going to look at a new topic, which is probability. And before we get started, I just want to say there is a page at the end for you to make notes and a task at the end. But between now and then, I just want you to listen. If you listen, rather than trying to copy things down and take notes, you'll take more in. And you can always go back and look at it again if you want to take notes at a later point. If there's something on the summary slide or there's something missing on the summary slide, then you can always go back. So just listening and trying to take it all in is the best thing you can do now. So probability. We're going to understand language associated with probability, to be able to calculate probabilities of certain events, and to understand the probability scale and how probability is usually measured. So hopefully you understand the concept of probability. It's the chances that things happen. Sometimes it can be described with words if we either don't know the probabilities or we just want to be vague. And sometimes we can calculate exact, specific probabilities when we know numbers and we want to be precise. We're going to look at both of those today. So first thing to talk about is the probability scale. Now I've got 5 points on there: impossible, unlikely, even chance, likely, and certain. And they're in the order of least likely to happen up to most likely to happen. And to explain them a little better, I'll show you an example for each. So impossible, I've got meeting with King Henry VIII. It's not possible. He's not around anymore, and so you couldn't meet with him. There's no chance at all that happens, so it's impossible. Now the day of the week starting with a T. If you think about it, there are 7 days. 2 of them start with a T. That's not many. There's 5 that don't. But if you picked a day at random, then there's a chance you pick one that begins with a T, but it's not a very big chance. You're much more likely to pick one that doesn't start with a T, so that's what we say unlikely, because it's more likely than impossible. It is a chance that it happens, but it's more often than not it doesn't happen, so that's unlikely. Then in the middle you've got even chance. Even chance is where it's just as likely to happen and not happen. They're both equally likely. So the next baby being born is a boy. If we think about boys and girls, and then if we think there's a roughly equal number, then it's roughly an even chance that the next baby born is a boy. Then we've got likely. Now I've said getting homework this lesson, and normally that would be likely because you get homework, or I make sure that I give out homework in the lesson on probability, but we're not having it today. So that just goes to show that sometimes likely things don't have to happen. Okay, so it's likely because it's more. It happens more than it doesn't happen, but it doesn't have to happen every single time. It's not certain. The next one's certain, and certain is a square having 4 right angles. That always happens. It has to be. If it didn't have 4 right angles, it wouldn't be a square. So impossible, even chance, and certain have got their fixed points. Impossible's right at the bottom. Certain's right at the top, and even chance is in the middle. But unlikely can go anywhere between impossible and even chance. It's just anywhere in between that. And likely can go anywhere in between even chance and certain. And some things are more likely than others, and some things are less likely than others or more unlikely. So let's have a look at putting some numbers on that scale. So the probability scale goes from 0 to 1. So you can't have a probability of 3 or 4 or -2. It's just from 0 to 1. Impossible things have 0 chance of happening. The probability is 0. Certain things that are certain to happen have a probability of 1. And if we look at a probability scale, you can see 0 right at the bottom in the impossible position. You can see certain right at the top in the, 1 in the certain position right at the top, and you got half right in the middle of even chance. And everything between 0 and a half is called unlikely, and everything between even chance and certain is called likely. So it could be 51 over 100, just a tiny bit above even chance, and we'd call that likely. Or if it was 99 over 100, that's still likely. It's just more likely than 51 over 100. And the same thing for unlikely events. If you had 1 out of 100, that's unlikely. If you had 49 out of 100, it's unlikely. It just has to be between 0 and a half to be unlikely, and it just has to be between a half and 1 to be likely. Probabilities are usually written as fractions or decimals. Now, sometimes a question will give you things in decimals, and therefore it's easier to work things out as decimals. But fractions are easiest if you're given a worded question, and we'll have a look at some worded questions to figure that out, why that is. Right, so we're going to have a look at calculating some probabilities now. Feel free to pause at each question and have a go at it yourself, or you can just listen to my explanation if you don't know what's happening. So we want to find out the probability of following events. So events is something happens, and what's the chances that this specific thing happens. So the first one, a coin landing tails up. So the thing which we're doing is flipping the coin, and we want to know the probability that a coin lands tails up. Now we're going to ignore anything silly like it landing on its side. Okay, and we're just going to consider that it's got 2 sides, heads and tails. In probability, we call those outcomes. So when you flip a coin, there are 2 possible outcomes. There are 2 possible things that can happen. One of them is tails, one of them is heads. Now, the answer for this is 1 over 2. It should be a fraction line there. I don't know why it isn't there, but it should be 1 over 2. And the reason that it's 1 over 2 is because there is 1 tail out of the 2 sides of the coin, which means that there's 1 success out of the 2 possible outcomes. We want tails. There's 1 possible way of succeeding, you get the tails. Out of the 2 possible outcomes, the heads and the tails. Also, we write P brackets tails because it's shorthand. We don't want to write out the probability of getting a tails is. It's too long. Let's look at another one. So we've got a spinner. We want to know the probability of it landing on a red section. So remember what we did. We want to figure out how many possible outcomes there are there when spinning the spinner, how many possible different things could happen. And that's 4, because you can see there's 4 sections. And how many of them are red? 1. So E brackets red, probability of red is 1 over 4. Again, there should be a fraction line there. Don't know why it's not there, but 1 over 4, because we've got 1 red section out of 4 sections total. Next one, drawing 7 of hearts from a pack of 52 cards. So if you didn't know, there's only 1 7 of hearts in the whole pack. So there's only 1 successful outcome out of 52 possible outcomes. So probability probability of 7 of hearts, we're going to say is 1 over 52, written as a fraction. Because there's 1 7 of hearts over 52 cards. And the last one we'll look at on this slide is a baby being born on a Friday. So we're going to just assume that every day is equally likely for a baby to be born. You can't really pick the day. So how many possible different days are there? There's 7. And how many of them are Friday? 1. So probability of Friday is 1 over 7. And this is why we use fractions. We use fractions because we can think of 1 out of this, 1 out of that, or maybe 2 out of this, or 3 out of that. And that's easier than decimals. You might know that a half is 0.5. You might know that a quarter is 0.25. You're not going to know what 1 over 52 is or 1 over 7 is as a decimal, but you'll easily know what it is as a fraction. Okay, so look at some more. So if we think about what I've just described that the probability of an event is the number of successful outcomes over the total number of possible outcomes. So going back to this slide, the number of successful outcomes, that's the numerator. How many ways can this happen over how many things can happen? So probability of an event, number of successful outcomes over the total possible outcomes. And remember that outcomes means things that can happen. How many different things that could happen when you do the thing. We've got a bag of marbles here. 1 yellow, 3 green, 4 blue, 2 red. And I want to know the probability of green. So the number of successful outcomes, that means how many different green ones are there? There's 3. Out of how many different possible things are there to take from the bag? How many different marbles are there? Count them up and you can see there's 10. So the probability of getting green is 3 over 10. You could say 0.3, but again, there's no need to, because 3 out of 10, it makes sense when you look at the bag of marbles. 0.3 makes less sense. Okay. We've got a spinner here. It's got 8 equal divisions, so it's 8 different sections. And we want to know what's the chances, what's the probability it lands on a red sector. So the red ones, you can see that there's 2 red ones out of 8, which simplifies down to 1 over 4. You don't always have to simplify probabilities, because if you think about it, 2 out of 8 makes a bit more sense than 1 out of 4, doesn't it? Because you can see there's 8 sections and 2 of them are red. A blue one, there's only 1 of those, so that's 1 over 8. And the green ones, there's 4 of those, which is 4 over 8, which you can simplify down to 2.5. Let's have a look at another thing. The dice we're throwing it. It's fair. We'll talk a bit more about what that word means in a minute. What's the probability of getting a 2? So probability of getting a 2. How many 2s are there on a dice? There's 1 out of how many different numbers are there? There's 6. So 1 out of 6. All of these should be fractions. A multiple of 3. So multiples of 3 on a dice are 3 and 6. So there's 2 of them out of the 6 numbers on a dice, which can simplify down to 1 over 3. Then an odd number. So odd numbers on a dice are 1, 3, and 5. And so that's 3 of the numbers out of 6, which will simplify down to 1/2. Then we're asked about a prime number. So prime numbers, they're numbers which are only divisible by 1 in themselves. So that's not 1 because it's only divisible by 1. So on a dice, the prime numbers are 2, 3, and 5. So that's 3 of them. 3 successful outcomes out of 6 possible outcomes. 3 over 6, that simplifies down to a half. A number bigger than 6. So how many numbers bigger than 6 are there on a dice? There's 0. There's none of them. There aren't any. So we can say 0 out of 6, which we should write as 0. You shouldn't write 0 over 6 because that doesn't make sense as a proper fraction. You should just write it as 0. Think about your probability line, your probability scale. 0 means impossible. It doesn't say 0 out of 6 or 0 out of 10. It just says 0. The last one, an integer. So you've got to know what that word means. An integer is a whole number. Well, they're all whole numbers on a dice. So that's 6 out of 6, which simplifies to 1 because it's certain. Think about your number line. Sorry, not your number line, your probability scale. Right at the top, certain, that's 1. Okay. So now, not this lesson, but next lesson, we're going to have a go at some questions from the book. And I just want to briefly show you all the different hints that are in there. So before you get stuck and you don't know what to do, make sure that you look over for these hints, because you can see in this one exercise, there's 9 of them. So a hint for one of them is writing the fraction with equivalent fractions, the same denominators. So that's if you want to compare different fractions, you want to write them as the same denominator. So equivalent fractions, double in the top, double in the bottom, that sort of thing. Probabilities, got a value between 0 and 1. You can use fractions, decimals, or percentages. I've already told you fractions, I think is the best, unless the question already starts with decimals, in which case you can stick with decimals. Successful outcomes, they're outcomes you want. So if you want to get a 6 on a dice, then getting the 6 is a successful outcome, and getting the 5 is not. Probability of an event happening, number of successful outcomes over total number of outcomes. And the formula only works for equally likely things. So you can imagine a spinner that has got 2 sections. One's red, but it takes up 3/4 of the spinner, and one's green and it only takes up 1/4. Even though there's 2 possible outcomes, they're not equally likely, so we couldn't use that formula in that case, but we won't have to worry about it in this case. An outcome is a result, so something that could happen. So flipping a coin would be an event. An outcome is getting a head. An outcome is getting a tail. One of the main things people can do wrong, if they talk about, tell me an event which is even, an outcome which is even chance, or something that's even chance, they say, okay, flipping a coin. And they don't say what they should, which is getting ahead when you flip a coin. Because flipping a coin, well, you flip the coin, there's no probabilities associated with that. You can't say something that's likely, roll a dice. That doesn't make sense, does it? So it doesn't make sense saying something that's even chance flipping a coin. So you've got to be specific with what you want. What's likely? Okay, rolling a dice and getting a number bigger than 2. That's likely. Flipping a coin and getting a head, that's even chance. Okay, then fair, that word I said. So it's not like a fun fair where all these games and flipping coins and rolling dice happens. It's fair means that there's no bias. Everything is as it's meant to. So it's not where it's more likely to hit on one section of a spinner than another. It's not that it's more likely to get one number on a dice than another. It's not that you're flipping the coin to try to manipulate it to get it to go or to come heads. It's everything is as it's meant to be. everything is equally likely to happen. When something says picking an event at random, it means everything's got an equal chance to be picked. If I say I'm picking a random student from the class, then that means anyone could be picked. Everyone's got an equally likely chance. I'm not looking at around the room and picking my favorite or least favorite pupil. It's random. If I say it's random, that's what it means. So you're not looking. If it asks what's the chances of picking a random sweet, which is green, you're not going to answer and say, well, I like green sweets, so I'm going to look in the bag and make sure that I pick it so it's certain. It's not what random means. It means you're going to pick them out without looking, and everything's got an equally likely chance of being picked. Then probability is associated with cards, and sometimes it will assume you know what cards are, and you know, jacks, queens, kings, aces, all the different things. So this just got a little hint to tell you what a picture card is. So if it asks what's the chance of a picture card, well, that's the chance of getting a jack, a queen, or a king. When you see the question, it'll make more sense. And then a strategy hint about calculating the probability of each event as a fraction. Like I said before, think of everything as fractions. It's much easier than decimals. Right, then we're going to get to the bit where you've got to do some writing. So what we've got on here is we've got the learning objectives and the heading, which I'd like you to write in your book. And I'd like you to make some notes from this page. I'll talk through them quickly. So I've got the probability scale, I've got the words, I've got the decimals, I've got the fractions, I've got the percentages, I've got the explanation of what's unlikely and likely. All probability adds up to 1, which means that if something happening has got a 0.3 chance, then the chances that it doesn't happen is 0.7, because something either does happen or it doesn't. The chances I win is 2/7. The chances I don't win is 5/7, because 2/7 and 5/7 adds to 1. So you've got to think about that. Okay. If there are 9 counters in the bag, 5 are blue, 4 are red. The chance of getting a red one is 4/9, because there are 4 successful outcomes out of 9 possible outcomes, assuming that we pick it at random and the event is fair. And in general, probability of X is how many X out of how many total things. So it could be about counters, sweets, socks, picking out random things, marbles, whatever. So I want you to make a note to this stuff in your book. What I also want you to do, to show you understand it, is next to impossible, unlikely, even chance, likely, and certain, I want you to write your own events. So write down something that's impossible, something that's unlikely, something that's even chance, something that's likely, and something that's certain. And I want you to put your own ones. I don't want you to copy the ones that were earlier in the video. I want you to think about your own ones. And once you've done that, photograph your work and submit it to me. Okay? So that's everything. If you need any more help, you can ask in the chat.